So in this video we'll look again at the RISC, but this time using AVO data as input. So we have per thread running and we are connected to center. We go back into the RISC module, and this time we are going into the AVO intercept and gradient tab, and the principle is very much the same. Here we have intercept and gradient that we're going to fill in. We open up the selection, we choose intercept data, and we choose gradient data. And the gradient data here is just a very simple far minus near. And with this procedure, we will be scaling that data. So again, these are relative values. And in the AVO RPT, we showed a method how to find the scaling factors. So before we go to the scaling factors, just quickly have a look at the uncertainty here. We have mentioned before that we have two different types of uncertainty as percent or absolute plus minus uncertainties. And for the AVO data, the uncertainties are in absolute plus minus. Again, the default values here, you can change them, but this is a good starting place. Now we have the scaling factors, and we had found the scaling factor for the intercept to be 0.0001, and for the gradient 0.0003. So let's use that and see how this plays out. This process here is of course iterative. So when we do the inversion and we look at the results, and if they are not fitting with what we expect at where we have the one log information, we have to go back and work on it, and maybe change, for example, the caprock properties. So having specified those, we go ahead to the output, and again there will be an initialization process of the IRPM. So we let that take place. We have some old information put in here, so I'm going to get rid of those and restart the process. So let's just allow this to finish. I have prepared my windows here, so now I have the intercept over here, I have the gradient over here, and I'm keeping these two ready to display the results for example, porosity and saturation. So let's just reset this, start from scratch. I'm going to choose inline. We know the well was around 89, right? So let's choose inline 89. Let's start with that. We could choose. We could have a look here and choose a cross line at the same time, which would be around somewhere around 352. So let's go ahead and do that. So I select the cross line 352, and then I want to calculate. So before we're looking at the most likely, let's do the weighted mean porosity, weighted mean volume fraction of shale, and weighted mean saturation. So we're going to do all of those, and we go ahead and we update. So we have center near AVO RPG, so we choose inline and cross line, and we choose over here. Let's look at the saturation first. And we need to change these color maps a little bit. Let's see where this is taking us. So we want this to be like that, and we want this to be like that. Oops. And then if we zoom in here, we can see porosity predictions around 30%, so a little bit lower than what we have in the reservoir. We have these two formations here. Let's bring in the well here also. It helps as a reference point. It's hiding because we're intersecting the exactly here. So let's push this one out a little bit. So we have here and here. This here is very strong red. When it's too strong like this, there's something off, and it's probably not matching the model, this formation down here. But when we have gradients like this, it can be more trusted. So we see that we have the hydrocarbons on there and down here as well. But and then we have a less hydrocarbon in the middle here in the predictions. Let's change this to look at the volume fraction of shale. Again, do a little color change. So we see that we have these sand formations here. These predictions are not super clean. I think that we should be going back and tweaking the scaling factors a little bit, and we will get better results. But this is showing the general principle. So the AVO RPT helps us get the general scaling factors. Then we need to go ahead and do the RISC on the AVO data and see what makes sense. This is maybe a little bit too strong in some cases, in some places here, and we need to tweak those scaling factors. We need to look at the caprock and have the iterative process until we get something that looks reasonable. So this shows the RISC AVO. We can go back to the input here, and for the angle stacks is again very much the same process. Then it's the near and far, and we just need to again put in those angles, representative angles to use.